So, hi guys, good morning. Welcome to NEET-World Institute and NEET-World YouTube channel. So, in this class, we are going to focus on the mechanical properties of solid. So, first of all, solid ante enti? Solid ante enti? Like మనం చూసినాం కదా, లైక్ స్టేట్స్ ఆఫ్ మ్యాటర్, సాలిడ్, లిక్విడ్ అండ్ గ్యాస్ అని. సో స్టేట్స్ ఆఫ్ మ్యాటర్ కదా. ఫస్ట్ థింగ్, వాట్ ఇస్ స్టేట్స్ ఆఫ్ మ్యాటర్? విల్ టాక్ స్టేట్స్ ఆఫ్ మ్యాటర్. ఇదే కదా మీకు మనం 9th and 10th లెసన్లో చూసిన స్టేట్స్ ఆఫ్ మ్యాటర్ అంటే. వాట్ ఈస్ ద మీనింగ్ ఆఫ్ మ్యాటర్? ఫస్ట్ ఆఫ్ ఆల్, లైక్ ఇట్స్ అ పార్టికల్, అంతే కదా. ఇట్స్ అ పార్టికల్, ఇట్స్ అ పార్టికల్. సో when we are talking about a particle, everything is made up of a particle. Everything is made up of a particle. Everything is made up of a particle. Made up of a particle. So this thing will relate with a solid, liquid and gas. Like 3 types ఉన్నది. సో మనం క్లాస్ 11thలో ఏం చూద్దామంటే మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్ గురించి చూద్దాం, మెకానికల్ ప్రాపర్టీస్ ఆఫ్ ఫ్లూయిడ్ అంటే 2 things. సో ఇన్ ఫ్లూయిడ్ విల్ టాక్ అబౌట్ అ లిక్విడ్ యాజ్ వెల్ as గ్యాస్ ఆల్సో. ఓకే, సో when we talk about a solid, like the particles are closely packed to each other, right? The particles are closely packed to each other, like n number of particles will be there in an object kada. N number of particles will be there in the object, right? So when we talk about a fluid, that is liquid as well as gas. So it is loosely packed, tightly packed solid మాత్రమే కదా. సో సాలిడ్కి మాత్రమే టైట్లీ ప్యాక్డ్ ఉంటుంది. లిక్విడ్ అండ్ గ్యాస్ ఇట్ ఈస్ లూస్లీ ప్యాక్డ్. అంటే పార్టికల్స్కి మధ్యలో గ్యాప్స్ ఉంటుంది. పార్టికల్కి మధ్యలో గ్యాప్ ఉంటుంది. అది గ్యాస్ చూసినామంటే ఒక పార్టికల్కి ఇంకొక పార్టికల్కి మధ్యలో గ్యాప్స్ అనేది ఎక్కువ ఉంటుంది కదా. సో హియర్ లైక్ ద డిస్టెన్స్ బిట్వీన్ ది పార్టికల్ విల్ బి minimum, like it's a tiny, okay. But when we talk about a liquid, excuse me, the distance between the liquid, I mean in liquid the distance between the particles is more compared to solid. Similarly, if I talk about a gas, distance between the particle is more compared to a solid and as well as liquid, right? So can I write like this? Gas greater than liquid greater than solid. అంటే ఎందుకు సార్, ఎందుకు ఇది చెప్తున్నానంటే డిస్టెన్స్ బిట్వీన్ ది పార్టికల్స్, డిస్టెన్స్ బిట్వీన్ ది పార్టికల్స్, ఓకే. సో ఇది బేసిక్ ఇన్ఫర్మేషన్ మనకి తెలిసింది. సపోజ్ ఒక ఫోర్స్ అప్లై చేస్తే ఏమవుతుంది, ఒక హీట్ అంటే టెంపరేచర్ రైజ్ చేసే బాడీ ఏమవుతుంది అని మనం చూడాలి. లైక్ ఇన్ సాలిడ్ చూడాలి, లిక్విడ్ ఆల్సో వీ షుడ్ సీ అండ్ గ్యాస్ ఆల్సో వీ షుడ్ సీ. వెన్ వీ టాక్ అబౌట్ a temperature rise in either solid, liquid or gas, obviously it will get expanded, right? No, this expansion we'll talk in the next class. The thermal expansion అని మనం చూద్దాం, ఓకేనా. ఆ థర్మల్ ఎక్స్పాన్షన్ గురించి మనం నెక్స్ట్ క్లాస్లో చూద్దాము. బట్ ఈ క్లాస్లో ఒక ఫోర్స్ అప్లై చేస్తే ఏమవుతుంది, ఒక ఫోర్స్ లైక్ స్ట్రెస్ అంటే ఏంటి, స్ట్రెయిన్ అంటే ఏంటి, డిఫరెంట్ టైప్స్ ఆఫ్ స్ట్రెస్ అంటే ఏంటి, డిఫరెంట్ టైప్స్ ఆఫ్ స్ట్రెయిన్ అంటే ఏంటి అని చూద్దాం. అండ్ హౌ ది స్ట్రెస్ అండ్ స్ట్రెయిన్ ఆర్ లైక్ అవర్ రిలేషన్, ఎవ్రీథింగ్ వీ విల్ టాక్ ఇన్ దిస్ క్లాస్, ఓకే. A basic information we will talk. I hope it's clear, right? Like this is the basic information we have talked in the class 9th and class 10th, right? No, so now the thing is, we'll go into the chapter that is mechanical properties of solid. So the first point is elasticity. Elasticity is nothing but when you try to increase the length of the object, or if you try to compress the object, when you release the force. For example, you are applying a force on an object, it will either expand or it will either compress. And suddenly if you are releasing the force on the object, what happens? It will try to regain its position or else it will stay as it is. When it regains its position, that property is called as elasticity. So the property of a matter by virtue of which a body tends to regain, this is the important point, tends to regain the original shape and size after the removal of the deforming force, that external force we are talking. Okay, the external force we are talking here. So for example, if I take an object, if I try to apply a force on this object, in 4 sides, okay, in 4 sides, what happens here? Like it got compressed. So this is my original, this yellow color is my original shape, and this other color which is none of the yellow color, no, so this one is my compressed shape. Okay, compressed shape. So if I try to expand the object, right, I should apply the force in the opposite direction. Here what I am doing, I am trying to push the object in 4 sides. When I try to pull the object in 4 sides, what happens? It will get expand. So leave the topic like pushing or pulling. The thing is, we need to concentrate on compressive and expansive, like compression and expansion we should talk. So after removing the deforming force, the object should regain its original position or a shape. That object is called as elasticity. That point is called as elasticity. Okay, suppose you might have you might get a doubt, if an object is not regaining its original shape or position, then what it is called as? Note point, when an object not regains its original shape, or size, okay, shape or size, then that is called as plasticity. So this plasticity is nothing but when I try to expand the object, it after removing the deforming force, what happens? It doesn't regain to its original shape or position. So elasticity example, you can take a spring. If you try to apply force in the for example, if you are trying to push the object, like pushing the spring, okay, if I take, this is my spring, this is the wall, if you are trying to push the spring, what happens? It will get compressed, no, it will get compressed. So obviously I can observe that there is a change in length. If I try to pull the spring, what happens? It will get expand. That's the example of the elasticity. So what is the example of plasticity then? So plasticity example, I can say, when you are trying to give the temperature for a metal, what happens? It will get expand, and if you suddenly taking the temperature away from the body, and that object will not regain to its original position. Okay, this is an example of the plasticity. Got it? So this is about elasticity and plasticity. Now we will talk about the thing, internal force and external force. I have told, no, like external force is acting on an object, so there might be an internal force also, like there will be an internal force also. So what is that? So external force is a deforming force, we will say. Okay, that's the point I have told in the previous slide. So internal force, this one will try to restore it, Restore it in the sense like if it is restoring, then I can say it's a elasticity. Restoring force is nothing but internal force, deforming force is nothing but external force. So now we'll go to that point. If you see here, so deforming force and regains its original shape and size. So this is internal force, this is due to internal force, and this deforming force is due to external force. Okay. Now stress, the first thing we are going to talk about is stress. So we have studied about stress in class 9th and 10th. What we have studied, stress is nothing but it is a force by area. A force applied on an object per unit area is called as stress. So force applied on an object applied on an object in a particular area. Okay, so applied on an object per unit area is called as stress. So basically you can say stress is nothing but force by area. So force SI unit is nothing but Newton and area is meter square. So SI unit is Newton per meter square. Newton per meter square is the SI unit. Got it? So we'll talk about okay. So stress, there are three types of stress. One is longitudinal stress, one is a bulk stress, and one is a shear stress. Okay, longitudinal, bulk, and shear. Okay, these are the three things. Longitudinal, I can say we can apply force in the end of the direction or in opposite direction. I'll draw the diagram. Once if I draw the diagram, you can understand. Okay. So first one is longitudinal stress, second one is bulk stress, and third one is shear stress. Okay, now we'll go into the topic, these three topics. So longitudinal and bulk, like in this thing we'll talk about this compression or expansion. So when we talk about a bulk stress, like we are talking about a pressure kind of things. Okay, a pressure kind of things we'll talk. So usually when we talk about a pressure, what is pressure? Force by area. So stress is also a force by area. Okay, and when we talk about a shear stress, this here the force is acting parallel to the object, Okay, so force is acting parallel to the object. Okay, this is about the three types of stress. Similarly, when we talk about a strain, what is strain? Strain is nothing but change in length by original length. So change in length usually will denote by delta L and original length is L. Okay. So when we talk about SI unit, it is nothing but no dimension. no dimension. Why, sir? Why no dimension here? Because length also will measure in meter, and L, that is other length, also will measure in meter. Change in length also meter only, length also meter only. When I cancel this one, it is no dimension. So when we talk about a stress, stress is force per unit area, so Newton per meter square, and when we talk about a strain, it is nothing but no dimensions. Got it? So whatever the types of stress we have talked, same types of strain also will be there. Okay, in strain, when we talk about a strain, types of strain, longitudinal strain, then bulk strain, then shear strain. Okay, so 3 types of stress, 3 types of strain. Okay. Okay, now we will talk about the stress, longitudinal stress, or else I can say it's a normal stress also, longitudinal. So longitudinal stress. So usually it is normal, we will say normal stress or normal force has been applied due to normal force. Okay, due to a normal force. Normal force in the sense, when I talk about when I take an object, a force is acting perpendicular to the surface. So if I keep the force in this direction also, it is perpendicular. If I apply the force in this direction, it is perpendicular. If I apply the force in this direction also, it is perpendicular. So when a force is applied perpendicular to the object and due to that a stress has been created, that stress is called as longitudinal stress. So longitudinal stress is nothing but perpendicular force by area. So what about the SI unit? Same SI unit, force is nothing but Newton and area is nothing but meter square. So this is about longitudinal stress. And bulk stress I have told it is due to a fluid, okay, when object is in a liquid fluid form, okay. So bulk stress. So bulk stress, like usually we will talk about a pressure. So pressure is nothing but again force by area, force by area. So what is the difference between the pressure and the stress? So stress generally have direction, but pressure doesn't have a direction. This is the basic information about stress and pressure. Stress and pressure. So stress is nothing but which has direction. I have told you here, in this case, due to normal force, when a force is acting perpendicular to the surface, perpendicular means obviously I should have some direction, right? But here the force doesn't have any direction, So stress is nothing but which has direction. And pressure is nothing but which doesn't have direction. This is the basic difference between the stress and pressure. Okay, the final one is if you see here, shear stress. Right now the final one is shear stress. So when you talk about a shear stress, force is acting parallel to the object. Force is acting parallel to the object. So parallel means what, sir? Parallel in the sense, when I talk about object, so force acted like this parallelly. Parallel in the sense, obviously the object will be looking like this, no? So the down part will be fixed but the upper part will try to change. So when I applying the force in parallel manner, this is how the object will look, and this is my theta, I can say some angle it has been made, right? So this was my original thing, so this was my original length, and this was my change in length, delta x I will take, or delta L also I can consider. Okay, now we will talk about a strain point. So strain in the sense longitudinal strain. So change in length by original length. So next one is bulk strain. So bulk strain, what we are doing is, there is an object like a liquid. If you try to give the pressure, what happens? It will try to compress, right? It will try to compress. So which is nothing but minus delta V by V. So this minus indicates the compression. Like volume only we are talking. So delta V by V. And finally, shear strain. It is nothing but how much angle it has been taken place. Okay, I can say it is nothing but tan theta, delta L by L. Delta L by L is nothing but tan theta. So I can say it is approximately theta, since theta is very small. So I can say this is the formulas for the shear strains. Got it? Okay, now we will talk about the Hooke's law. So basically Hooke's law means what? Like Hooke's law is nothing but stress is directly proportional to strain. Stress is directly proportional to strain. So to remove the proportionality, we are adding a constant called alpha, the modulus of elasticity. Okay, so I can say that modulus of elasticity is equals to stress by strain. Modulus of elasticity is nothing but stress by strain. So what is the SI unit? SI unit is Newton per meter square only for this also, modulus of elasticity also, because Newton per meter square is the SI unit of stress and there is no SI unit of strain. So obviously the only SI unit is Newton per meter square. Got it? Okay, so in modulus of elasticity there are three types. As we have talked about stress, there is three types. As we talked about strain, there is three types. Usually when we talk about a Hooke's law, that is modulus of elasticity, here also three types. One is Young's modulus, one is bulk modulus, and one is rigidity modulus. Okay, Young's modulus, second one is bulk modulus, and third one is rigidity modulus. Okay, this is the three thing. Okay, so Young's modulus is nothing but the longitudinal stress by longitudinal strain. So F by A divided by delta L by L. This is the formula. When we talk about a bulk modulus, it is nothing but the pressure, that is pressure, no? So pressure by delta V by V, and this is negative we will keep. Okay, and rigidity modulus is nothing but, what is the rigidity modulus? The force, here perpendicular force, here the parallel force by area, and it is divided by the theta. So these are the formulas of the modulus of elasticity, which is nothing but Young's modulus, bulk modulus and the rigidity modulus. So this is the basic information of the mechanical properties of solids. So when you come to the class 11, we'll talk a detailed thing in the solid spot, okay, as well as the fluid spot also we will talk, okay. So until we are going to meet in the next class, I'll take a break from you guys. Thank you, bye bye.